Okay, so the next problem involves finding the equation of a tangent line, which means that we need to find a point on the curve and the slope of that point. Okay, so we're going to first start off with if x equals pi over 2, we really should know the y value or the y position of that. So if I plug in pi over 2 into this, cosine of pi over 2 is 0 times pi over 2 is 0. So the coordinate that we're looking at is pi over 2. X is pi over 2, y is 0. If your notes have that little p there, that should have been a pi. So I also need a derivative, so I'm going to differentiate, so I need slope. This is a product, so I need to make sure I apply product rule, so it's going to be 1 times cos x plus x times negative sine x. Okay, so I end up with cos x minus x sine x. So I want to know the slope at pi over 2. So I plug in pi over 2, I get 0 here. Pi over 2, sine of pi over 2 is 1. So I end up with a slope of negative pi over 2. So there's my slope. That's equal to m. Okay, I've got my coordinate. I now just have to plug into my equation of a line. Okay, I'm going to use a point slope form. That's the most convenient. Slope is negative pi over 2, x minus pi over 2, y equals 0. For number 6, these are implicit functions, so we need to remember how to differentiate implicitly. We differentiate the x's normally, and the y's are treated as embedded functions. So as I differentiate this, I'm going to differentiate the power first, but every time there's a y there, I know that there's an embedded function, so I need to apply chain rule and differentiate y to y prime. Minus 2x equals 0. We can leave it like that. However, usually what's implied is we want to solve for y prime. So we end up with 9y squared y prime equals 2x. So my y prime is an implicit function, so we need both the x and y coordinates to find the slope. Okay, so there's my derivative. Here we have product rule, so I'm going to differentiate the x, times it by y, differentiate the y, which means I'm going to get y prime, so there's my product of those two. When I differentiate the x's, I don't really do anything different. When I differentiate the y's, I have to make sure I apply product rule. Sorry, the chain rule. It's implied we solve for y prime, so I'm going to group my y prime terms. So it's going to be 3x plus 2y and factor out the y prime. Everything else goes to the other side, so the negative 4x becomes positive 4x on the other side. 3y is minus 3y. Isolate the y prime. I end up with 4x minus 3y, all divided by 3x plus 2y. Okay, so there is my implicit derivative.